In this video, we're going to be using the definition of a derivative to solve derivatives. So if you're looking for a video that goes into more depth as to what a derivative is or where the definition of a derivative originates from, this is not going to be a helpful video for you. So with that said, let's go ahead and get started. The definition of a derivative is defined as such. F of x equals the limit as h approaches 0, f of x plus h minus f of x over h. This is exactly what we will be using for 7 different examples. So this is something that you're likely going to want to memorize or remember. Make it familiar to you. Let's go ahead and start with an easy example. Okay, this right here is going to be our first function. F of x equals x cubed. Let's find the derivative. So, please recall that the definition of a derivative is f prime of x equals the limit as h approaches 0, f of x plus h minus f of x over h. So, anywhere that you see an x in our original function, right here, you're going to add a plus h. This is what that will look like. The limit as h approaches 0 is x plus h cubed, and the cubed comes from right here, our original function, minus f of x right here, and f of x is just our original function, which is just x cubed, over h. This is step 1. So now what we're going to do is expand this right here. If you know how to do that already, that's great. You can go ahead and skip ahead a little bit more. If you don't, you're going to want to listen up because this is important to learn right now rather than later. Okay. X plus h cubed is really just the same as doing x plus h times x plus h times x plus h. And you can try to distribute it 1 by 1 by 1 by 1, but that's just going to take too long. So normally what you're going to want to do is use the perfect cube formula, which is a plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b3. So if we apply that to our example right here, which is x plus h3, the ending results will be x cubed plus 3x squared h plus 3x h squared plus h cubed. Really right here, our a is just equal to x and the h is equal to b. That's how it's being applied. Okay, so let's return to our original equation here. So this will equal the limit as h approaches 0, x cubed plus 3x squared h plus 3xh squared plus h cubed minus x3. Don't forget to add this x3 right here, okay? And all of this will go over h. Now, let's just try to get rid of some things. So we have an x cubed and a negative x cubed. These two will get rid of each other. And there is no other way to simplify anything else. So our ending result will be the limit as h approaches 0, 3x squared h plus 3x h squared plus h cubed over h. Yes, that looks good. So now you see what's something that these three right here have in common. They all have an h, right? So we can pull an h out, and what we'll get from that is the limit as h approaches 0, h 3x squared plus 3x h plus h squared over h, right? So we just took an h away from each of these, and then these two will cancel out, leaving just this right here. Yes, that looks right so far. Let's move on to the next step. Okay, so now what we're left with is the limit as h approaches 0, 3x squared plus 3xh plus h squared. And there's no way to simplify this anymore. So what we're going to do is anywhere that you see an h, we're going to plug in a 0, which is going to look like this. 3x squared plus 3x 0 plus 0 squared. So 0 squared is just 0, and 3x times 0 will leave us with 0. So we're left with 3x squared. This will be our final answer. So the derivative of f of x cubed is this right here, 3x squared. Let's move on to our next example now, which will be a lot more complex than this one. But this is how we learn. Okay, here we go. Example 2. F of x equals 4x cubed minus 1. No one be intimidated, we'll get through this together. Again, let's remember that the definition of a derivative is f prime of x equals the limit as h approaches 0, f of x plus h minus f of x over h. Okay, now anywhere we see an x in our original function, we're going to add this h. So this is what it would look like. The limit as h approaches 0 is 4 x plus h cubed minus 1 minus f of x, don't forget, which is just our original function, which is 4 x cubed minus 1 over h. Yes? Okay. And just like the previous example, we're going to distribute this right here. Same thing as last time, it's just this added 4 right here. Okay, so that's going to look like this. The limit as h approaches 0 is 4x cubed plus 4h cubed plus 12x squared h plus 12xh squared minus 1. Everything you see right now, I just used the perfect cube formula on what we originally had right here, and this is the result, okay? Then we're going to bring down this right here. Don't forget to distribute this negative sign right here, so that'll turn into minus 4x cubed plus 1 over h. Okay, so we have a positive 4x cubed, a negative 4x cubed. Those would get rid of each other. We have a negative 1, a positive 1. Those would get rid of each other. And there is no further way to simplify this, so we're just going to write it down. Limit x minus x, the limit as h approaches 0, 4h cubed plus 12x squared h plus 12x h squared over h. So just like last time, let's try to find something in common. And you see this one has an h, this one right here has an h right here, and this one has an h. So we're going to bring an h out to see how much we can simplify this. So the limit as h approaches 0, pulling that h out will give us h 4h squared plus 12x squared plus 12xh over h. Again, these h's would get rid of each other, which leaves us with the limit as h approaches 0, 4h squared plus 12x squared plus 12xh. So this is when it can't be simplified anymore, so we're going to go ahead and plug in a 0 anywhere you see an h. That will look like this. 4, 0 squared plus 12x squared plus 12x 0. This will leave us with 0. 12 times x times 0 equals 0. 0 squared, 0 times 4, 0. So our final answer is going to be 12x squared. So our original function was f of x equals 4x cubed minus 1. The derivative of this is 12x squared. Okay, now we're going to go to the next example, which might be even worse than this one, but that's okay. We'll get through it together. Okay, here we go. Example 3. F of x equals 4 over x. Let's find the derivative. F prime of x equals the limit as h approaches 0, f of x plus h minus f of x over h. We're going to do something a little bit different first. We're going to go ahead and pull this h out right here to make it a lot more simpler because we already have a fraction right here. So this is what that's going to look like. It's the limit as h approaches 0, 1 over h, f of x plus h minus f of x. These two right here, they're equal to each other. It's the exact same thing. I only just pulled the h out because it's just going to simplify things for us. But they are the exact same thing. So again, anywhere that we see an x in our original function, we're going to add that extra h. So let's go through that. Okay, 1 over h is going to be 4x plus h. That 4 comes from up here, our original function, and the x plus h just goes in the bottom right here. All right, okay, minus f of x again, just our original function, which is 4 over x. Okay, not so bad so far. Now what we're going to do is try to find a common denominator with these two right here. We're going to go ahead and bring that work over here. So we have 4 plus x plus h minus 4 over x. Okay. Okay, so now we're basically going to go back to pretty elementary math. So we're going to times the 4 by the x, and the 4 up here by the x plus h, and that's going to give us our common denominator. So what we'll end up with is 4x over x times x plus h minus 4x plus h over x plus h. So now we can see we have a common denominator, so we can go ahead and work through this a bit more. Let's just go ahead and combine these two, and that'll leave us with 4x minus 4x plus h over the same common denominator, which is x times x plus h. Okay, so we're going to go ahead and distribute this 4 a bit more, turn it into 4x and 4h. So that's going to look like 4x minus 4x plus, oh, sorry, not plus. It's actually going to be minus. Sorry about that. 4x minus 4h over, scroll down a bit here, x times x plus h. So maybe you've already noticed, but the positive 4x is going to get rid of the negative 4x, right? So that's going to leave us with negative 4h over x times x plus h. This right here is going to be what we're going to plug back in over here, because there's no way we're going to simplify that anymore. So now we're left with the limit as h approaches 0, 1 over h, and remember this turned into negative 4h over x times x plus h. Okay, so this h, 1 over h right here, is going to get rid of this h up here. So we're going to be left with, let me scroll down a bit, we're going to be left with the limit as h approaches 0, negative 4 over x times x plus h. And it becomes intuitive, but you start to realize when you get to a point that there's no way you can further simplify, and that's when we're going to start plugging in anywhere with an h with a 0. So that's going to look like this, negative 4 x times x plus 0. That'll turn into, if you distribute this x right here, It's going to give us x squared. This is going to go to 0. So our final answer is going to be negative 4 over x squared. That will be our final answer for this one. Remember, our original function was f of x equals 4 over x. So the derivative of this function is negative 4 over x squared. Wonderful. Let's move on to the next example, which is going to be much easier, but it's going to get a lot harder and longer after that. Okay, the function is f of x equals 7x. Let's find the derivative. Remember, the definition of the derivative is, f prime of x equals the limit as h approaches 0, f of x plus h minus f of x over h. Again, anywhere we see an x in our original function, we're going to add that extra h. So for this one, it's going to look like this. The limit as h approaches 0 will give us 7x plus h minus f of x, our original function, which is 7x, over h. So our next steps are going to be to distribute this 7 right here. So that's going to give us 7x, and this is going to give us 7h. Let's write that out. So the limit as h approaches 0 is 7x plus 7h minus 7x over h. Okay, and maybe you can already see it, but this 7x right here is going to cancel out with this negative 7x. So that's going to leave us with 7h over h, and these h's will cancel out. So our final answer is going to be 7. Remember, our original function was 7x, so the derivative of 7x is 7. Okay, let's move on to example number 5. That one's going to be long and heavy, but maybe you feel prepared enough already. Okay, I lied actually. This one isn't going to be that bad, but the final two are really going to drag out, but they're also the kind of questions that are on exams. So anyway, for this example, our function will be f of x equals 6 minus 12x. Okay, the definition of a derivative is f prime of x equals the limit as h approaches 0, fx plus h minus f of x over h. Okay, remember, anywhere that you see an x in our original function, we're going to add that extra h. F of x is always just our original function. So what does that look like? Here we go. Limit as h approaches 0 will give us 6 minus 12x plus h minus our original function, which is 6 minus 12x over h. So right here, we're going to have to distribute that 12 to the x and to the h. And right here, don't forget to add this negative. This is something that trips a lot of people up, but don't forget to distribute that negative. That'll always mess you up. So this will give us the limit as h approaches 0, 6 minus 12x minus 12h minus 6 plus 12x over h. and you check to see if anything cancels out. So you see this positive 6 will cancel out with this negative 6. This negative 12x will cancel out with this positive 12x. And that will leave us with, it'll leave us with a negative 12h over h. And these h's will cancel out, which will leave us with negative 12. And that's going to be our final answer. Remember, our original function was f of x equals 6 minus 12x. So the derivative of this function is negative 12. Now let's move on to our last two examples, see how we do. Okay, here we go. Now we've gotten to the fun stuff. Example 6. Our function for this one will be 20 plus 10x minus x squared. Okay, this one is still not going to be as bad as the final one, but it'll still be a little bit different from the ones we've previously done. Okay, so remember the definition of a derivative is f prime of x equals the limit as h approaches 0, f of x plus h minus f of x over h. And we're going to approach it the same. Anywhere you see an x, we're going to add a plus h. The f of x will always just mean our original function. The problem with these ones is there's so many numbers and so many things you have to distribute and keep track of. It's not necessarily hard, it's just more things to keep track of, but let's take it slow. Okay, so this will give us the limit as h approaches 0, and it'll be 20 plus 10 x plus h minus x plus h squared minus our original function, which is 20 plus 10x minus x squared over h. Okay, so here we're going to have to distribute that 10. That's going to give us 10x. This is going to give us 10h. And this right here is similar to what we've done in previous questions, but because it's a little bit different because it's not cubed, it's squared. So let's go ahead and move this work up here. This is how you would do this one. So we start with x plus h squared. And again, you're just doing, let's ignore the negative for now, but you're just doing x plus h times x plus h. That's all you're really doing. So if you distribute the x right here, this will give you x squared, this will give you xh. So we have x squared, that's a comma. We have xh, so then if we distribute this h, you have hx, which again is just another xh. And then you have an h squared. So organized, you have x squared plus xh plus xh plus h squared. But xh plus xh is just going to give us 2 plus 2xh plus h squared. But remember, we have to come back and distribute this negative sign right here. So our final product will be minus x squared minus 2xh minus, plus. No, minus, I'm so sorry. I apologize. Sorry again, minus h squared. So we're going to go ahead and plug all of that back into our original work. Okay, so the limit h approaches 0 will give us 20 plus 10x, remember, we're distributing, plus 10h minus our x squared minus 2xh minus h squared minus our original function. Again, don't forget to come distribute this minus sign right here. It'll turn into 20 minus 10x plus x squared over h. My hand is cramping. Okay, so let's see what cancels out. So already I see positive 20 will cancel out with the negative 20. The negative 10x will cancel out with the positive 10x. The negative x squared will cancel out with the positive x squared. And that will be it. So what are we left with? Let's write it out. The limit as h approaches 0. I don't know where that dotted line came from. Just ignore it. So that'll leave us with 10h minus 2xh minus h squared over h. So then we go back to our original principles. What do they have in common? An h, an h, an h. So let's go ahead and try to pull an h out, see what happens. So the limit as h approaches 0 will give us, pull out that h, 10 minus 2x minus h over h. And these two h's right here will get rid of each other. So that'll leave us with just 10 minus 2x minus h. Yes. And again, you get to that point where you realize you can't simplify it any further. So this is where we plug in anywhere with an h with a 0. So that'll leave us with 10 minus 2x minus 0, which simplifies to 10 minus 2x. And this right here is our final answer. So remember, our original function was quite long. It was 20 plus 10x minus x squared, and the derivative of this is 10 minus 2x. Yes, that one was a little bit longer, but it's really just keeping track of more numbers, a few more steps, but it's honestly less calculus and more back to algebra. But let's go ahead and move on to our final example, which will be similar to this one with just a few more steps and a bit longer. Our final function is going to be f of x equals x cubed minus 4x squared plus x plus 9. And we're going to solve the derivative by using the definition of the derivative, which is f prime of x equals the limit as h approaches 0, f of x plus h minus f of x. And really, once you master it, once you master the definition of the derivative, things will become a lot easier because you won't really need it once you learn the product rule, the chain rule, stuff like that. This is really a simple derivative to solve, but when you're using the definition of the derivative, it just becomes very long, but it is important to learn. And sometimes it is easier to use this format, and it might be easier for you, so we're going to go through it. Okay, here we go. Remember, anywhere that you originally have an x, you're going to add that extra h. F of x will always just mean our original function. This one is going to be quite long. Maybe you've already realized it, but because we have a cube right here, we're going to go back to that perfect cube formula. And because we have the square right here, we're going to use the perfect square formula, which we've used in previous examples. I just didn't say it specifically, but okay. So we will have, the limit as h approaches 0, and we're going to have x plus h cubed minus 4x plus h squared plus x plus h plus 9 minus f of x, which is our original function, so x cubed minus 4x squared plus x plus 9. And don't forget to put that all over h. If you think this is long, it's about to get a lot longer. So here we go. We're going to use, this right here is where we're going to apply the perfect cube formula. And this right here is where we'll apply the perfect square formula. So let's do it first with the cubed. So x plus h cubed, again, is just x plus h times x plus h times x plus h. And if we apply the perfect cube formula, which again is a plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. And here this a is going to equal our x and the b is going to equal our h. So that is going to give us x cubed plus 3x squared h plus 3xh squared plus h cubed. So this right here is what we're going to plug back in. And now let's go to the square. So we're going to have negative 4x plus h squared. And again, this right here is just x plus h times x plus h. It's just the addition of that negative 4 that might throw you off. But the perfect square formula is similar to the perfect cube formula. It's a plus b squared equals a squared plus 2ab plus b squared. So for our example, that would give us negative 4x squared minus 8xh minus 4h squared. So this is what we're going to plug in. So this one is going to be plugged in place of this one, and this one will be plugged in place of this one. And then this right here will stay the same, as will the plus 9, and for this one right here, we're just going to distribute this negative throughout all of these, which is really just what we've done, again, just more steps. So our final product will be really long, but this is what it's going to look like. Okay. The limit as h approaches 0 is, okay, x cubed plus 3x squared h plus 3xh squared plus h cubed. Remember, that's exactly what we got for our answer up here in green. So now for the one in blue, we're just going to plug that in as well. So we'll have minus 4x squared minus 8xh minus 4h squared. Hopefully everyone's following along so far, but remember the plus x plus h will stay the same, as will the plus 9. And then if we distribute that negative sign, we will end up with negative x cubed plus 4x squared minus x minus 9. And don't forget all of this goes over h. So let me go ahead. So this green right here, we just simply plugged it in right here. This blue answer that we got right here, we just plugged it in right here. And these highlighted in red, we just brought down from below. But these right here, we distributed that -1 sign. Okay, hopefully you're still following along. But our next step here is to eliminate what we can. So let's just look through it one by one. Already, I see that this +9 will get rid of this -9. This positive x will get rid of this negative x. Let's see what else. This positive 4x squared will get rid of this positive 4x squared up here. Okay, this positive x cubed will get rid of this positive x cubed. I don't believe I missed anything, but let's see. So this will shorten what we have so far a lot. So we're left with 3x squared h plus 3x h squared plus h cubed minus 8xh minus 4h squared. Okay, we're just going to go back to how we've previously done things and try to find something in common. And again, it's that h. Anywhere I've drawn underlined in blue, you see there's an h. So let's pull out an h and see what happens. It'll simplify things a lot more. So we pull out an h. That leaves us with 3x squared plus 3xh plus h squared minus 8x minus 4h plus 1. That plus 1, even though we take an h from an h, it'll still leave a 1. Don't forget that, or that'll mess you up. So this one, h minus h, will give us this one right here. Okay. Hopefully that doesn't confuse anyone. Let me get rid of that. Okay. So again, this h will get rid of this h, and that'll simplify things down. Oops. So the limit as h approaches 0 will leave us with 3x squared plus 3xh plus h squared minus 8x minus 4h plus 1. And you can tell that things aren't going to simplify down more than this. So this is where we can plug in a 0 for anywhere we're seeing h, which would be right here, and right here. Let's scroll down a bit. Okay. So that'll leave us with 3x squared plus 3x times 0 plus 0 squared minus 8x minus 4 times 0 plus 1. So this will leave us with 0, this will leave us with 0, this will leave us with 0. So what we'll end up with is 3x squared minus 8x plus 1. And this right here will be our final answer. So remember, the original function that we started with was f of x equals x cubed minus 4x squared plus x plus 9. And the derivative of this will equal that. I will link a PDF of all of the work that we've done in the comments of this video. Hopefully you'll be able to see that. I'll explain things a little bit more with some text rather than verbally, and maybe you can use that to follow along to rewatch the video.